Welcome dear students. So today we are going to start a new chapter and the name of the chapter is Factorisation. So basically this particular exercise, that is exercise 13a, is the introductory video on factorization by taking out common factors. Now first and foremost you need to understand what is the meaning of common factors. So if you see in all these questions, today we will be solving these many questions. Now in all these questions you will find this, right? So these are called terms. Okay, so this first term, this second term. Okay, so terms, will remember, terms will be separated by plus or minus sign. Okay, if there is multiplication or division, then it won't divide into terms. Okay, so only plus and minus divides the given numbers into different terms. For example, here we have got 2 terms, here we have got 3 terms, here we have this 1 terms, 2, and this is my third term. Okay, so this is how we talk about terms. Okay, now in each and every terms you see that there will be some numbers which are same, okay, or some factors which are same. Okay, so if there are same factors, then you have to take that factor out, okay, and that is called common factor. Okay, so taking out common factor, that is what we call taking out common factors. So for example, in this particular question, okay, so in first term we have 15x, in second term we have 5. Okay, do we have x in the second term? No. So we don't have x here, so that's why I cannot say that x is a common factor. Now 5 is there in the second term, 15 is there in the first term. Now do 15 contains 5? Obviously yes. Okay, so when you, okay, so if you want to write 15 in terms of 5, can you write this as 5 into 3x? Can you write it? Okay, you have plus 5. Okay, I told you this multiplication sign won't divide the given term into 2 different terms. This entire thing is considered to be one single term. Now in this term, this is my first term and second term, which factor is same? Can you say that 5 is same? Yes, so that's why in this case your answer turns out to be take out 5 outside. So from the first one only 3x is left. Now since this 5 is gone, so you have plus sign. Now 5 is gone means only 1 will be left. So that's why your first answer will be 5 into 3x plus 1. Okay, so this is the factorization of this particular thing by taking out 5 as common factor. Now in the second question, there are no numbers present out here like this. We see only the variables, that is a and a. So that's why we say a is a common factor. Now how many a's are here? Only 1, because nothing is there in the power means the power contains 1. Okay, so there are exactly 1 a, here we have got 2, here we have got 3. Okay, so the minimum power has to be taken as common. Remember, minimum power has to be taken as common. So we have minimum power to be a, so that's why only a will be the common. So if 1 a is gone, so out of 3 how many are left? We are left with only 2, because 1 is gone, right? We have minus sign. Now out of 2 1 is gone, so only 1 is left, plus now this a is gone outside means only 1 is left. So that's why the answer for this particular question will be this much. Isn't it very simple? Yes. Okay, let's see this one now. In this question, see 4 here. Okay, so let's have a look at the numbers here. So number is 4 and 8. Now 8 contains 4 or not? Yes, because this 8 can be written as 4 into 2, isn't it? Okay, so that's why we have 4. If you take 4 common, okay, so 4 can be taken outside because this 8 can be written as 4 into 2. Okay, now let's see the variables out here. So here we have a, here also we have a, so that means we can take a as common. Now let's see what is the minimum power of a. Here the power of a is 2, here the power of a is nothing, that is 1. So that's why only the minimum power has to be taken outside. Okay, now Here in the second term we have b, but in the first term we don't have b, so we cannot take b as common. Alright, so when 4 is gone, okay, so from number, when 4 is gone, we don't have any number here. Okay, now out of how many a's are there? There are exactly 2 a's, isn't it? If one is gone, one a is gone, so only one a is left. So number is number present here? No, number is gone. Now out of these 2a, we have got only a left. Okay, now minus sign is there. Now 8 is 4 into 2, 4 is already gone, so we are left with 2 as a number, a is gone, and we are left with b, isn't it? So that's why your factorization become 4a into a minus 2b. Okay, let's see the next one. So you see this 15 contains 5 and 3, whereas this 20 contains 5 and 4. So basically in between 15 and 20, what is common? We see that 5 is common. Okay, so that's why take 5 as common. Here we have x to the power 4, here we have x to the power 3. So minimum power is x to the power 3, so that's why x to the power 3 is gone. Y cube, y to the power 1, that is, so y is common because the minimum power is 1 here. Okay, so now see here carefully, 5 is gone, so how much is left? 3 is left. X to the power 4, so x cube is gone, so out of 4, 3 is outside, so that's why only 1 is left. Y cube, see here carefully, out of 3 y's, 1 is kept outside, so that's why here exactly 2 y's are left, minus, see 20 is 5 into 4, 5 is gone outside, so we have only 4. Okay, x cube is gone outside, so that's why there is no x here. Now whatever y is also gone outside, so that's why y is also not present. So that's why your factorization of this particular question will be this much. This is your answer. Okay, I hope the thing is clear to you. Now these were the easy ones. Let's have a look at the bit tougher questions. Question C is factorize this particular thing. Now here number 17, here 34, here is 51. Now you know 34 can be written as 17 into 2 and 51 can be written as 34 is 17 into 2, 51 is 17 into 3. So this also contains 17, this also contains 17, this also contains 17. That means 17 can be taken as common. Okay, now let's see how many a's are there. There are 6 a's, 4 a's and 2 a's. So minimum is 2, so that's why we'll take 2 as common. Now this is b to the power 8, b to the power 6, b to the power 4. So what is the least power of b? It is 4. So that's why b to the power 4 will be common. Now in this case 17 is gone, so no number is present. Now out of 6 a's, 2 are gone. So how many are left? Exactly 4 a's are left. Now 4 b's are gone, so out of 8 exactly we have 4 b's left. Minus, I told you 34 is 17 into 2, 17 is gone, so only 2 is left here. Okay, so out of 4 a's, 2 are gone, so exactly 2 a's are left. Okay, now out of 6 b's, 4 are gone, so that's why we are left with exactly 2 b's. Plus sign is there, so 51 is 17 into 3, 17 is gone, so only 3 is left. So a square is also outside, b to the power 4 is also outside, so that's why this is just b square. I'm sorry, this is just 3 here. Okay, a square is also gone, b to the power 4 is also gone, so only 3 is left. So that's why your answer turns out to be this much for question number 9. Okay, let's see question number 11. So in these question, x square is there, see there's into sign here. Okay, there's into sign here, there's into sign here, there's into sign here. So in this case this becomes my first term, this becomes my second term, and this becomes my third term. Now in first term we have x square, in second term we have y square, and in third term we have z square. So x square, y square and z square, they are not same, they are not common. But here we see that a minus b, a minus b, a minus b is same, isn't it? So that's why if I take a minus b common, this is common factor, right? Because there is into sign, remember. Okay, now if you take a minus b common, here we have x square left minus a minus b is gone, means y square is left, plus now a minus b is gone, means only z square is left, isn't it? So that's why your answer becomes this much for this case. Pretty simple, isn't it? Similarly, here we have into sign, isn't it? So this becomes my first term, and this becomes my second term. Here we have x plus y, here we have x minus y. Are they same? No, right? So we have a plus b here, we have a plus b here, so take a plus b as common. Okay, now if you see here carefully, we have x plus y left from the first term, we have plus from the second term, we have x minus y. Okay, now open the bracket, so we have a plus b. Okay, so now you can, okay, so let me write this bracket only for now. So we have x plus y plus x, plus into minus is minus, we have y. Okay, so see here carefully, plus y and minus y gets cancelled. X plus x is how much? It is 2x, isn't it? So let me write this 2x in front. Okay, we have a plus b left. So this is my answer for this particular question. Let's take one more similar kind of problem. I'll directly jump to question number 16 for you. Okay, now this becomes my first term, this is my second term. Okay, now there's plus sign, that means this becomes my third term. Now if I ask you, tell me a number or a factor which is present in all. Here we have a plus 2b, here also we have a plus 2b, here also we have a plus 2b. So that's why a plus 2b becomes my factor in this case. So from the first one we have 3a plus b minus, this is gone, so we are left with a plus b. We have plus sign. See, here we have how many a plus 2b? We have exactly 2a plus 2b, right? So 1 is gone outside, so how many are left? Out of 2, if 1 is gone, so only 1 is left. So we have a plus 2b to the power 1, no need to write that power. Okay, now open the bracket, a plus 2b. Okay, so 3a plus b, minus into plus is minus a, minus into plus is minus, we have b, plus we have a plus 2b, because plus into plus is plus itself, right? Now see here carefully, plus b minus b gets cancelled, plus a minus a gets cancelled, isn't it? So how much is left now? Ultimately we have a plus 2b here, and here we are left with 3a plus 2b. Okay, 3a plus 2b. All right, so this is my answer for this particular question. So you may pause the video and note down here all the solutions. With this we close for the day. Thank you very much.